All right, welcome everyone. Thank you for coming to our June webinar, talking about things happening in Arizona, weather and climate-wise. And we're going to go ahead and get started first with just some background information. We have our guest speaker, Mike Crimmins, we're so grateful for, who will be talking a little bit more depth about what the monsoon actually means, what that is. If you have any questions for us, please enter questions in chat, and we'll wait until the end after we get through all of our voluminous slides. We have a lot of slides for you today, so we want to get through those. And if you have any questions, of course, we're happy to answer those. We are recording this right now, and we'll be putting it up on YouTube and linking that out. So very, very grateful to have all of you here to talk about these kinds of things going on in Arizona. So I did put out a tweet with a poll and asking folks, when does the monsoon season begin? It really wasn't a trick question. I grew up here in Arizona, and so I had different triggers and cues for me as to when the summer thunderstorms would happen. Monsoon, when we look at that term, the definition of monsoon is a seasonal reversal of winds. And so when we say monsoon season, it's kind of redundant a little bit, but that's the term that we use now, starting in 2018, when, there's a lot of background as to what's happened with understanding the monsoon thunderstorms, how that operates in the summer here in Arizona. But it's not just in Arizona, California, New Mexico, Utah, Nevada, Colorado, they all can have summer thunderstorms related to the monsoon season. And so in 2007, Tony Hefner, who was the meteorologist in charge at the National Weather Service here in Phoenix, proposed the idea of starting June 15th to September 30th as our monsoon season. And so that's what we're welcoming today, coming into the season, so that we're all in it together and we have these ideas together. So then in the 60s, really, the concept of the dew point temperature. So just a little bit about the dew point, what that is. It's a temperature when condensation occurs. So the higher the dew point temperature, the more water in the atmosphere, really. And so looking at research that happened in the 60s with the state climatologist, Paul Kangeiser, and the meteorologist in charge at Phoenix, Bob Ingram, they came up with the idea of 55-degree Fahrenheit temperature 3 days in a row. That's the average 55-degree Fahrenheit temperature for the day. And so looking at that as enough moisture in the atmosphere to really understand and build those convective thunderstorms. And it relates to what we call precipitable water, something that we measure with our weather balloons every day. An inch of precipitable water is enough really to give us the juice that we need to get our summer thunderstorms, our convective thunderstorms. Precipitable water, what that is if we were to look at this pretend column of air above us and we were to condense all of that water, how much would we get out? And so an inch of precipitable water usually is enough to give us a go at our thunderstorms. And so that's a little bit of a history on that. So whichever one you prefer, I welcome all of them. And you can see there, I always, when I grew up here, my parents would never turn on the oven in the summer until we had a thunderstorm, and that's when they would have cookies. And so that's my trigger and cue that I associate it with. A little bit of the dew point legacy kind of statistics for Phoenix. We need that 55-degree Fahrenheit, 3 days in a row average dew point temperature to say, okay, this is the onset of the monsoon. That's the legacy statistics that we have. And so kind of keeping track of those, we do here in my office, we keep track of them currently and go back until about 1948. You can see there aren't any really big changes in what's been going on with our monsoon here in the Phoenix metropolitan area. The monsoon typically lasts around 70 days or so, 71 on average. And then when you look at active days, so when do we have dew point temperatures that are 55 degrees or higher, enough ingredients in the atmosphere to get those thunderstorms, those are on average about 55 days within that monsoon season. We call those burst days or active days. And we're not really seeing any change there as well, but it's interesting to keep track of these things for sure. Now, kind of comparing what we've been experiencing here in Arizona, it's been absolutely amazing as we've had cooler than normal temperatures. And kind of as a climatologist, what we look at are what are called analogs. Have there been similar times in the back years when we had these kinds of same things happening? It gives us some information to understand what we may expect, kind of to look at those analogs and kind of see where we're going. And so as we've progressed through last June, we had a really wet monsoon season. We had a really wet winter. That kind of aligned with what happened in 2018 and 2019. So we look at these kinds of things. You're looking at 500 millibar height anomalies. This is where we can kind of see, do we have low pressure, high pressure? And so we call that low pressure troughing. And so you can see those in blue on our maps here. So both of those years, when we're looking at 2018, 19, 2022, 23, similar in what the atmosphere was looking like through that period of time. And so kind of understanding how that looked with our wet summers and wet winters. So if we go back and look at June through March 2018-19, and then our June through March last monsoon through this wet winter, you can see that, both of them were really high precipitation. We had a lot of precipitation in various different places of the state, but the analog comes through with looking at our anomalies of where are the high and low pressure kinds of setups. And so absolutely we had anomalous troughing, which means it's been colder than normal because we've had these low pressure trough systems in our area, which has kept things cooler. Now, what can we expect? Well, we can just pop back and see what happened in 2019 with the monsoon. Not saying that that's going to happen this monsoon. We do know that when it's colder in, January, February, March, when we have more snowpack in the higher elevations, that lasts a little bit longer, which it did this year, that kind of delays the onset of our monsoon. So just taking a peek at looking at the monsoon of 2019, June through September, it was the 11th driest on record. By any means, that is not a forecast, but it's interesting to take a look at. Now, for the past 12 months, as I mentioned, it's been amazing. So you're kind of looking at some of these charts, the way we keep track of these things. You look at normals, you look at kind of the highest percentiles of those. And so the last 12 months are shown by the blue line on that chart that's going up and down. And you can see that we've had great precipitation June through May, well above average. And we also keep track of water, looking at water years. And so a water year runs from October through September. It's kind of how we keep track of our water in the state. And so we're October through May now. So we've been going for a few months. We've got 8.92 inches for the state, which is the 27th October through May so far. And in order to get to our normal or average amount of water year precipitation, we only need 3 inches and a third, and that'll get us kind of average. So hopefully we can get some of that for the state this summer. We can look at calendar years, so you can go January through May. We've had 5.81 inches for statewide, and that is the 23rd wettest. And in order for the calendar year to give us that average amount that we need, we'll need another 6.5 inches or so. And then for winter, December through March, it was exceptional, the 19th wettest. So we're very grateful for that precipitation. Always happy for that. Statewide temperatures, as we've mentioned, have been cooler than normal. If we go back to October, you kind of see one of those charts that shows that blue line showing where our temperatures have been, and they've been diving down below that kind of average darker gray line these last few months, which has been amazing. And so you're looking at a map that's showing you temperatures across the state, and you can see some places are a little bit colder. through that period of time. So looking at that starting point of our water year, October 1st to present. So we're all grateful for that as well. And how that really plays out. It not only it feels great, we can go outside. We're not worried about our little puppies' feet on the cement as we're taking them for a walk. It's been amazing. But other impacts, we're not turning on our air conditioning as much. And then we're not taking as much water out of the soil. So soil moisture is that water that's found in that first layer of the soil. That's what the plants will suck up to feed themselves with the water. So we're measuring soil moisture. And it's been amazing here in Arizona as well. So looking at from last May, we still have great measures of soil moisture. What that means when we're looking at colder temperatures, not putting as much water into the atmosphere, allowing it to retain in the soil, that helps us understand what may happen with our wildfire season. So these are put forward as outlooks. And you can see here for June, there have been below normal kinds of conditions in Arizona, which is really welcome, and we're grateful for that. And as we move to July, August, and September, we move to normal amounts of wildland fire potential. So please remember, we're in Arizona, and wildfires are part of our climate system. So when it says normal outlook for Arizona, there is wildfire potential. And so we do have the Wilbur fire, which has been burning. You can see the smoke plumes from that. And that was lightning caused on May 21st. And so that still is burning a little bit. They're watching it very carefully, slowly letting it move through kind of normal conditions. But there is still potential for wildfire as we get hotter, especially this weekend. We're going to be getting hotter, and that's going to start desiccating some of the plants as well. When we're if you're in the Phoenix metro area, you may have recently smelled some of the mulch fire that was smoldering out east. I actually saw that combust, or well, the results of it, as you saw the smoke go up. And then living out east, we would smell that smoke. Smoke is measured as particulate matter 2.5. So whenever you see PM 2.5 measures, that's what we're talking about, is that smoke. And here in the Phoenix metropolitan area, especially, we have a diurnal wind. We have a wind that moves back and forth on a daily basis. And so folks in Mesa and Tempe and Gilbert would start smelling that smoke during the morning as the east winds would push that smoke down along the 60, along the 202, and we would smell that. Fortunately, it's been cleared out, but be mindful of how winds can push the smoke and impact you. No changes in our short-term drought since April. This is not unusual. May and June are the two driest months of the state. And so having those conditions kind of maintain at where they were over the winter, maintaining with really only 1% of moderate measures of drought in the state, and that's up in Mojave County. You can see it there. It's been a great way to start what we're going into here with our summer. So no changes in short-term drought since April. And then long-term drought, kind of looking at where we stand there, that moisture that we've been experiencing. We had 2 wet monsoons in a row, which has been great. We had a wet winter, which is great. Prior to that, we had 2 dry winters. And so you can kind of see that we still have some of that long term, looking at what's been going on for 24 months, 36 months, 48 months. And we also take into account temperatures, not just lack of precipitation or too much precipitation. We look at how much water will move into the atmosphere as well. And so that's what we're looking at here with our long-term drought. Still looking much better than we were a couple of years ago. You can see May 2021 was exceptional and extreme in many parts of the state. June, when we're looking at our outlooks for the end of June, what we're expecting, you can see that that Arizona is still looking to be below average through June. Precipitation may or may not be average to below average. So that's where we're standing right now. And still uncertain about monsoon. We've recognized that the monsoon will be delayed because we really do need to get that ridge of high pressure building in that Four Corners region. So we'll see. This is seasonal outlook is for June, July, August, dated the middle of May. So we'll take another look as we go and pay attention to what we can expect as we go through. And then El Nino is making its way. The conditions are present and expected to gradually strengthen in winter. What tends to happen with El Nino in the summer, not so much influencing what's going on with the monsoon, may influence later August, September, October, November, when we get tropical systems coming in down in the Tucson area. Perhaps we might have a greater helping hand around that time, but not really so much with our monsoon. And so thank you for your time here. Statewide, grateful that it's cooler, helping those soil moisture conditions. Just need a little bit more precipitation to get us to that average amount for our water year, and expecting El Nino to have impacts, as it strengthens. So we'll pay attention to that as well. So I'm going to stop share and we'll let our guest speaker come on in. And as Mike is coming in, let me go ahead and introduce him to you. So grateful. I've known Mike for several years now, and he's faculty on the Department of Environmental Science at the University of Arizona. And he's an extension specialist in climate science for Arizona's Cooperative Extension. We work together quite a bit with drought at statewide levels at the Drought Monitoring Technical Committee. He's been in his roles for 18 years working with ranchers, farmers, natural resource managers across Arizona, helps integrate climate information in their planning and their decision making, and assisting them in developing strategies to adapt to a changing climate. So grateful to have you, Mike. Thank you. It's all yours.
Thanks, Erin. I really appreciate it. Sorry for the title. I actually am going to talk about the entire state, not just Southeast Arizona. This won't be very Tucson-centric. And thanks again for having me. I am not a native Arizonan. I'm a monsoon enthusiast over the last 20 years. And so this will be my 22nd monsoon here in Arizona. And it's just been a blast to try to understand it and learn about it over time. So what I thought I would do is just talk a little bit about some of the aspects of the monsoon that make it really quite unique to Arizona and to the Southwest, and why it's such an important season for us. But I want to make that distinction early on, the difference between the winter and summer patterns. And Erin did a great job, because she really pointed out that we have this kind of hangover of our winter and spring pattern lingering right into the monsoon season. And we need to have a transition basically happen before we get into the core of the monsoon. So the typical winter circulation pattern is exactly as Erin was pointing out, was that we end up having troughs of low pressure systems swing across the Western US. And so typically we're under the influence of a high pressure system most of the time. When that is retreats to the south, we can have these low pressure systems move from west to east, drop down here, and give us precipitation. And we saw this activity all the way from last fall through the winter and into the spring. And that's what gave us these wet conditions. We even saw it into the later part of the spring as well. And we still kind of see this pattern hanging on across the west and the southwest. And the moisture that comes from those systems is really from the northwest. Occasionally we'll have the system reorganize and break down and actually pull in subtropical moisture across the entire Pacific Ocean. We would call those pineapple expresses, or now kind of the new nomenclature is atmospheric rivers. But largely that's from higher latitudes. And you can see that the tropical moisture, which are those blues and greens and purples, is far to the south at this point. The more of the moisture is to the higher latitudes and from the north. So we're dragging that from the west and from the northwest. So when we get into the monsoon season, and this is really the progression we're looking for right now, is the building of the subtropical high pressure systems across the lower latitudes. So the East Pacific subtropical high, so that's a high pressure system. Mid-levels of the atmosphere, flow is around it clockwise in the northern hemisphere. And that is important for us to actually drag in that moisture from the south. And so we can see here that that map from the winter and now into the summer, the purples at the higher latitudes, the higher levels of moisture at the higher latitudes is now up over Canada. There's a large dome of dry air that's cool, dry air off the Pacific Ocean across much of the West. Now look south, we start to have all of this moisture move up the spine of the mountains in Mexico, and it really is coming in off of the East Pacific. And that's a really important transition that we're looking for, hopefully in the next 4 to 5 to 6 weeks. Okay, so just to put a little finer point on this transition here is that high pressure system, those two big H's, we're looking at kind of mid to upper levels of the atmosphere. So that flow on the north side of that high pressure system is coming from the west and moving to the east. This is in May. In June, you can see it building north, and it's building over the landmass areas, predominantly here in the western US. And then as we move into July, it's now progressed overhead, and then hopefully it'll move a little bit to the north or northeast of us as we move into July. And so that's that, we're waiting for that heat event, really. So we always have that burst, we feel that burst of heat right before the monsoon, and it really is related to the high pressure system building overhead and then hopefully moving to the north of us. And so those are those hot days that are coming. They really do have to come prior to the onset of the monsoon to see that transition and that swing from southwesterly winds of the upper levels of the atmosphere to south and southeast. And that is what the monsoon is it's that seasonal change in wind direction in the upper levels of the atmosphere. Okay, this is a big complex graphic, but I just want to show you just a couple of finer points here. And it moves from the top of the graphic to the bottom through time. And this is all climatological progression here. So it's June 15th in the upper left corner. It's the same maps of the upper level high pressure system flow here. And you can see it's to the south over Mexico. We move down the column here. It moves a little bit further north. That's kind of the peak of the onset. And then by July, we're kind of hanging out underneath that ridge. Hopefully it's a little bit further to the north. And it quickly starts to recede back to the south. So it's this progression of the upper level high pressure system overhead, a little bit to the north, and then it will recede gradually through August. And by September, we're really out of that flow again. And those storms that we do get in September are typically of tropical origin. If we're going to get any of those big rain events, they're going to be recurving tropical storms. So these other columns just show you the commensurate impacts that we would see with that. The greens here just show the progression of the precipitation up through Mexico, reaching into southern Arizona and hopefully up through the rest of the state, the quick retreat. And these are variables like precipitable water, just the amount of moisture in the atmosphere. You can see that reaching up the Gulf of California into the low deserts. And then this final column is something called convective available potential energy. It's a fancy term for the amount of instability in the atmosphere. And so those purple to light purple to white colors are going to indicate when we have that instability in the atmosphere. So climatologically, you can see it sort of pulsing in, kind of breathing into the southwest and then retreating quickly in September. And I like to think of this is kind of an old concept, but thinking about air masses and transitions. In that previous graphic a couple of slides ago, where we saw that all that dry air across the western US, moist air to the south, is really about an air mass transition. So that movement of that high pressure system to the north is going to start to introduce and pull in the moist subtropical or the maritime tropical air mass that is hanging out to the south related to the tropics, that is introduced and pulls into the northwest across Arizona. And if you've ever done any kind of drives across Arizona in the monsoon season, when it's in transition, you know that you can be in very hot, dry wind in Las Vegas, move down to Phoenix, and it could get a little bit more humid. But if you're on your way to New Mexico, you could drive right through thunderstorms as you get to the southeast part of the state. So we can have these really hard edges to the tropical air mass in the monsoon. The last couple of summers, the air mass has just flooded into the southwest, taken over the low deserts of California and moved north, and we've just been sitting in the soup. That's not always the case. We can kind of always be on the edge in Arizona as this boundary goes back and forth. This is a kind of a pixelated graphic here, but you can kind of make out that same progression of time here. This is satellite derived rainfall, and you can see June in southern Mexico progressing up to middle of Mexico by June 25th, and then it should reach us not too long after. And so we're already paying attention to the activity in Mexico. So you have to look south to watch the progression north, and it's been quite quiet just because of that trough that's been hanging out across the west. So we will, I know, all expectantly be looking south now to watch that activity as it moves north. Here's a little cartoon graphic to try to put some of the big pieces together kind of at the core of the monsoon season. So as we get into July and into August, we're looking for the position of the Four Corners high, that big H over the Four Corners there. Hot conditions in the lower Colorado River Valley, which is actually, it's a thermal low at that point. It's so hot, so much rising air. Those kinds of machinations and that flow in the atmosphere can help draw in moisture off the Gulf of California. So we also need the Gulf of California to very quickly warm up so it can give off a lot of moisture. So we're actually looking at that as a metric. And then we'll be looking for that activity to the south. And so all of that is we're at the far northern reaches of the monsoon. So we have to watch this progression and all these pieces fit together to give us those really good widespread monsoon days. I think this is a really cool study from 2018 where some researchers looked at points across the Southwest and then tried to look backwards from rain events. So they took very, very rainy days during the monsoon and used this model that would look backwards to see where the moisture came from. So the yellows and greens and blues mean that that's climatologically where the moisture was coming from the rain events for these locations. And so you can see here, if you look at some of these, Cedar City up in southwestern Utah is getting most of its, if not all of its moisture coming in off the Gulf of California. If you go over to Colorado, you can see it's kind of coming in from lots of directions from the Southwest, from recycling of rain events that we're having here in Arizona. Levine, just south of Phoenix here, real strong fetch right off the Gulf of California. And then if we look at someplace like right on the Arizona-New Mexico border in New Mexico, this is kind of an interesting location where as you go a little further east, you can actually start to get Gulf of Mexico moisture that's being pulled into the Southwest. It's got to move over some mountain ranges, so it's not as an effective pathway as coming right off the Gulf of California. But in that area, you can actually see the moisture come from both directions, which I think is kind of interesting. So predominantly in Arizona, Gulf of California, but we can have moisture work in from the east at low levels in a little more challenging way. Okay, so just looking at the progression monthly, June, climatologically dry. We can start to see activity work into the southeast part of the state, and that's typically where it'll happen first. July, it reaches up the Mogollon Rim. Higher elevations are favored. The southeast part of the state really gets into the action. In August, that's our peak month. You can expand out a little bit more in the lower elevations. We typically will get some more widespread events in August. And then by September, really by the 10th, the 15th of the month, we're kind of out of it again. And so we're really going to see tropical storm activity could be the biggest way to get us some widespread activity. So total average precipitation, putting those all together, really amazing amounts of precipitation some of these higher elevation locations are getting, can get over 20 inches, 15 to 20 inches in the monsoon season at the highest peaks. And then just a couple of final stats here. Percent of annual average precipitation. I always find this really striking to look at this map is that the southeast part of the state gets predominantly more than half of their precipitation from the summertime monsoon season. Whereas you go to Phoenix, it's a little bit more even. And it's just such a harsh boundary as you drive out of Tucson. There's that shift in the balance of precipitation. And as you go into Southeast Arizona, that is much more monsoon country and much less of the wintertime precipitation than even the rest of the state. And then the activity across the state in that lower right there is the average number of days of precipitation that we would see during a normal monsoon season. Can be some locations will see precip on half of their days, and those are typically the high elevation mountains that are driving that convection. And as you get down into the lower elevations, it's a little harder to come by, right? So you might see 10 days or 15 days on average during a monsoon season. So you have to look to the mountains to watch that activity and then hope it rolls downhill and gets us in the valley locations. And that's including in the middle of Tucson. Monsoon really is a spectator sport. We often are watching it from afar and really celebrate when it actually was able to come home. So I'm going to actually leave this part out, and I'll just do a quick closing here and just leave you with a couple of points here is that Arizona has this unique seasonal transitional climate, this different winter versus summer, and we need to transition from a winter pattern to a summer pattern to get into the real essence of the monsoon. And it's a critical ingredient to support thunderstorms, which is that moisture being drawn into the region from the summer, from the movement of the subtropical high. And as we all know, they're highly variable in space and time. Your neighbors can get clobbered and you might not, but then hopefully the next day it'll kind of reverse fortune and you'll get that. And they do vary from year to year, but they aren't persistent over time. And it's really a challenge to forecast. And so we'll really have to kind of wait and see what we're going to get this season. So again, thanks, Aaron, for having me. And I think we're at time, but if there's time for a question or two, I can take that.
Thanks so much, Mike. Yeah, if anyone has any questions, please enter those in chat and we'll go through those. That was an excellent overview of our monsoon season. So grateful for that. Thank you. And we'll give folks just a second if they have any questions. And I'm grateful for that. So what are we thinking for this? Yeah, it really is just wait and see at this point in time, isn't it? We're just kind of looking around. Do we have enough ingredients? Are they coming together?
Yeah, I'm with you too, Aaron. And I think that we were talking at the beginning, I think it just feels late. You kind of feel it in your bones right now. It just doesn't feel like it's setting up quick enough. I think we've both been through monsoons, though, that they can have a very quick reversal and it proves you wrong. But I just kind of feel like it's going to be late this year.
I think it's been that case that we've learned to just kind of wait and see because we've been through that. Okay, so we do have a question. What is your estimated date for 3 days of 55 dew point this year? Oh my goodness, Mike.
So I can do the Tucson one, and it's because we're both climatologists. I'll probably just go with climatology. So climatologically, it's funny in Tucson, our definition is 54 days, and we're just a little bit higher elevationally, which gives us a slightly different dew point threshold. And so climatologically, we would hit it about the 4th or the 5th, and I'm kind of feeling like it's probably going to be the 10th or the 12th before we start to really get into the deeper moisture.
Right, and same with Phoenix. We're gonna get it a little bit later. And I didn't see any questions about the donut of Phoenix, but just FYI, what Mike was talking about, where some people get clobbered with rain and some people don't. Part of that is our elevation in Phoenix. We have to have those storms typically coming off the rim. They're high elevation. They have to be moist enough to make it all the way down to 1,100 feet elevation in Phoenix and not evaporate. So those things are very real. All right. Thank you very much for your time. I'm grateful for everyone. We'll be talking next month. So if you haven't signed up, let me know. You can come to our website and I will be able to send you information for our next webinar. Thank you, everyone. Have a great day.